Well, good morning, everyone. Yeah, I'm Finlay Scott. I work for the Joint Research Centre for the European Commission in the fisheries team. My talk this morning is really about how we use R to provide scientific support for policy, in particular sort of fisheries policy. I'm going to assume that there's not many people here who have much of a background in fisheries, so we'll spend a little bit of time at the beginning just sort of setting some context. So the initial question is, okay, what is a fishery? Now, the FAO have a really broad definition of what a fishery is, which is an entity which is engaged in harvesting or the growing of fish. So it's kind of broad. This is a sort of a simple diagram of a marine ecosystem. I should say that I'm going to be focusing on wild marine fisheries, so we're not talking about aquaculture or freshwater fisheries here. And so in this ecosystem, we have at the top right, we have the fishing vessel, which is doing some fishing activity, and he's managed to catch some of the small fish, which is down at the bottom left of the picture. I realize I'm pointing, but there's 4 screens, so this isn't terribly helpful for people. There is some small fish at the bottom left, which he's successfully caught. So the fishing activity is impacting on the stock, but this isn't the only thing that's going on, of course, because the fish don't live in isolation. They are also affected by ecosystem interactions from all the other wonderful animals that live in the sea. And there's also environmental variability and environmental drivers that are affecting it too. So when we talk about fisheries management, we're really talking about how the fishing activity is affecting the stock, but that's only one small part of a wider picture. If we turn to fisheries management, you could generally characterize sort of the management cycle as to be something like this, particularly sort of across Europe. This cycle tends to happen on an annual basis. So at if we start at the top right, which is sort of the management process. So here, some kind of decision is made about how the fishery should operate, probably in the following year. So typically this might be something like setting a limit on what the total catches can be. The fishing fleet then interpret these instructions, and they go out and they go fishing, and of course this fishing then has an impact on the biology. And then we, as scientists, sit in the bottom right of this picture, and we receive data from the fishing fleet. This is normally in terms of catches or sort of the actual amount of fish that they caught, and data also from the biology, which is life history parameters, and if we're lucky, some kind of index of relative abundance, maybe from a scientific survey. So we have to perform some kind of quantitative analysis on this data we get, and use that. We then provide advice, which goes back up into the management process. Of course, it's not simply a one-way street. There is an iterative process that goes on there. So what kind of quantitative analysis are we required to perform? I've tried to boil it down to sort of 3 fairly simple questions. The first one is, where are we? This is about estimating stock status. Fish are tricky because they live in the sea, obviously, and that makes it very difficult to actually observe them directly. So if we're trying to estimate literally how many fish there are in the sea, we have to use some kind of modeling tools. Normally the data we get, as I said, is some estimate of catch data. So we know how many fish were removed, and the trick is now to work out, well, how many were there to start off with. If we think we know where we are, the next question then becomes, well, where do we want to be? So we compare sort of the estimate of stock status to some reference points. And this allows us to think about, well, are we fishing too hard? Is the stock abundance too low? Conversely, could it actually be fished a little bit more, obviously with regards to sustainability? And then the final question is, well, if we think we know where we are, we know where we want to be, and then of course, well, how do we get there? And this is where we start talking about the evaluation of management plans. And in the European Union, the main policy driver is the common fisheries policy. So one of the key elements of that is that fisheries should be managed under multi-annual plans. But before a plan can be adopted, it has to be evaluated, and it's evaluated using computer simulations. And then you test your plan against lots of different assumptions and uncertainties to make sure that it's robust and can achieve its objectives. When we're thinking about this scientific advice and how it needs to be provided to policy, there's obviously lots of qualities about this scientific advice which would be useful. Number one, it has to be robust. We would like it also to be transparent and reproducible. It has to be clearly communicated, which is really important given the amount of uncertainty that we're dealing with. And of course, we would like to use open source tools where possible. Now, generally across the European Union at the moment, I don't think there's any sort of real guidelines for adopting the qualities of transparency and reproducibility in open source. However, there is a growing recognition that these characteristics sort of really enhance the quality of the scientific advice. And there's some movement there. So there is now a European Union public license, which is an open source license, and that's compatible with many other open source licenses. So we have some need to do statistical modeling. We have these sort of policy requirements that we'd like to have. And of course, you add them together and you think, well, R must be the solution for doing that kind of thing. If we take a little step to the side, back in 1998, there's a fisheries scientist called John Schnute. And he compared the number of software tools and languages available for fishery science with the myth of the Tower of Babel. And the conclusion he came up with was the cosmic plan for confounding software languages seems to be working remarkably well among the community of quantitative fishery scientists. So his thinking was that actually across all the different research institutes around the world, fishery scientists were actually performing sort of the same sort of work. So there's an awful lot of reproduction of effort was going on there. And everyone was using their own set of tools that they were building in their own sort of different languages that they were using. So not only was there reproduction of effort, but actually it was very difficult to start pulling everything together into a coherent framework. And really maybe what we wanted was some kind of domain-specific programming language for fisheries that would enable us to sort of be a bit more coherent with doing this. So with that in mind, the FLR project was born, and it was born in about 2005, I think, using R 2.1, which seems a long time ago. And this was an effort that was a collaborative effort from various research institutes sort of around the world, particularly funded by sort of European Union projects. And the idea was that it would build a library, a collection of tools for a quantitative fisheries science developed in the R language, to facilitate the construction of bioeconomic simulation models of fisheries systems. Fine. And it does this fairly well. Of course, it has the qualities we like. It's fully open source. It's extendable and adaptable. It's mainly written in R. There is quite a lot of C++ in there, as well as some automatic differentiation. It's mainly built on S4 classes, which I'll touch on in a little bit. And of course, we're in the R framework, so it interacts very nicely with all the other R packages that we have. If we sort of take a very brief look at the FLR ecosystem, the main package we have is this thing called FL Core, and from that, lots of other packages basically come out from it. So if we return to the where are we question, it's the packages over on the left-hand side, which is responsible for doing the stock assessment to estimate stock status. If you want to know where we ought to be, then you use the things for advice and forecasting, so Flash and FLBRP. And then there's some other packages for doing plotting. So there's one for linking nicely with Lattice and also with ggplot2 as well. And then there's some more sort of fishery-specific stuff that goes on. The nice thing is that you can knit all the different classes and so on within the packages to start building up some larger scale simulations. As I said, we make a lot of use of S4. This produced some challenges because we started using S4 back in its sort of infancy. And it seemed that every time a new version of R came out, everything would break. We'd have to go back and sort of rethink everything. But there's a lot of inheritance going on. There's a lot of overloading of methods and so on and so forth. Although after going to Winston Chang's talk yesterday, I'm probably going to think about rewriting the entire thing in R6. So what kind of stuff do you actually do with it? What are the important things? Well, this is just some kind of output from running a stock assessment to estimate stock status. And the kind of information that you get back out of it, starting from the top, we have recruitment, which is the number of baby fish that we've estimated there are. The SSB, which is the spawning stock biomass, so the biomass of mature fish that we think will go on to produce baby fish. And we also have estimates of catches, and we have estimates of F, which is the fishing mortality, which is a really good indicator of the impact of fishing. And we also have an estimate of uncertainty around these values as well. The plot on the right-hand side is just F, but it's a wireframe of age and year. Now, the interesting point isn't that we've got a stock assessment model, because there's lots of stock assessment models. I think what's more interesting is that it's possible to incorporate a range of stock assessment models within the FLR framework. So even if you've got a stock assessment model that's not necessarily written in FLR or R, so long as you can call it from R and get the results back in, you can put some kind of wrapper around it and then sort of integrate it more into the FLR framework, which gives you access to all the other sort of exciting, wonderful tools that we have. And I think it's really this ability, particularly in terms of stock assessment, that's produced a lot of uptake of FLR. So there's the International Council for the Exploration of the Sea, which is responsible for performing most of the stock assessments around Europe. They use FLR a lot in their working groups to assess the status of European stocks. Not necessarily with stock assessment models that have been written for FLR, but just using other models which we've managed to integrate into it. More complicated stuff is management plan evaluation, and this is sort of a large-scale simulation where we attempt to simulate the entire management cycle that we saw at the beginning. So not only do we simulate the fisheries dynamics and the biology, which is in the top bit there in the operating model, we also try and simulate the management procedure and the stock assessment and the management decision and so on. And because we've got all these different classes available in the packages, it's really a case of sort of putting everything all together to sort of run this big iterative simulation framework. One of the interesting things is that there's lots of different, for example, biological growth rate models. And so because we've got this sort of common framework, we're able to sort of pop out one model and put in a different model, or try a different stock recruitment model and try another one. The important point is that you're testing your proposed management plan against a whole range of different assumptions and different uncertainties, because you have to make sure that your plan is robust to all of this, because in reality, you don't know the true situation. This kind of approach, I think, is really powerful, and it's been used a lot by some of the RFMOs, which is the regional fisheries management organizations, such as the big tuna RFMOs that do evaluations in the Indian Ocean and also for tuna in the Atlantic as well. And they've been using FLR to do these kind of simulations. The graph on the right was just a really simple example I was trying to put together, where the aim of the plan was to hit do I have a mouse? No. Anyway, was to hit a certain level of F. On the bottom panel by 2030 was to try and get there. And I proposed two management strategies of getting there. One of which was to cut F immediately and then go along at my target level, and the other way was to carry on at a sort of a status quo level and then cut it down. The point is that the end point is reached in both of them, but the trajectories in getting there are both very different, so you have much wider uncertainties and sort of different trajectories. So you need to test how these things are going to go. Moving on towards the end, it's very important for us to sort of do capacity building and spreading the word. So we have all these packages, we have the website, there's vignettes for the packages, there's tutorials, but one of the things we're really keen on is running courses, and we try to run a course at least once a year. And I think this photograph was taken at the end of one of the week-long courses. Astonishingly, people are still smiling in it, despite being hit over the head with R and FLR for a week. Maybe some sort of Stockholm syndrome is starting to set in by this point. Okay, so in conclusion, we think that FLR is able to meet the scientific needs for policy. It's able to produce robust advice. It's also able to meet some of the other policy needs that we have, such as transparency and sort of openness and so on. It has quite a lot of uptake. As I said, it's used a lot by some of the tuna RFMOs for doing these kind of simulations. It's also used by the International Council for the Exploration of the Sea. And we also use it in the STCF, which is the European Commission sort of fisheries science wing for performing a lot of the management plan evaluations in the EU. We're reasonably good at disseminating it for such a mature project. So we have a sort of 30-odd scientific articles and about sort of 200 or so citations for some of those articles. And this is just a sort of an important thing that I found the other day, and actually my dad pointed this out. This was a story from the Times from a couple of days ago, which is that North Sea cod is back on shelves as stocks recover. And this has got two interesting things, one of which there's a positive fisheries story in the news. This is really rare and unusual. And the second thing is that the North Sea cod evaluation, so the evaluation of the management plan and the stock assessments, were done using FLR. So we're not taking any credit for this, but it's nice to know that a project you're involved in is being used for something that seems to have some sort of positive results. So just got to thank the FLR team, so Iago and Esto, and Laurie in particular. And yeah, there's the website, and if you've got any more questions, then come and find me. Thanks.